In this video, we will explain about synchronous DRAM. DRAMs whose operation is directly synchronized with a clock signal. That is a synchronous DRAM. Cell array is same as in a synchronous DRAMs. The address and data connections are buffered by means of registers. Output of each sense amplifier is connected to a latch. A read operation causes the contents of all cells in the selected row to be loaded into these latches. But if an access is made for refreshing purpose only, it will not change the contents of these latches. It will merely refresh the contents of the cells. This is the block diagram corresponding to synchronous DRAM. This is our cell array. There is a raw decoder, column decoder, then read-write circuits or sense amplifiers, latches. Then the I/O lines are buffered by means of data input register and data output register. Data output register is used for outing data. During the read purpose, this register will be read. And data input register is used for writing purpose. Data to be written will be placed into this data input register. Then raw decoder will select a row from the array, and that data will be available at the read-write circuits and latches into the latches. Then column decoder will be used to select one group of latches or bits from the selected row. That will be available through the data output register. Then here we have row address latch. This row address latch is used to latch the row address. And that address will be decoded by row decoder. Then column address counter. This column address counter will act as a latch, and also this will be this is a counter. So the column address will be latched into the column address counter with the help of column address strobe. Similarly, row address will be latched by means of row address strobe. Okay. Then this has one more feature, that is this acts as a counter. So this can increment the value of the column address latch automatically. This will help in the case of a block data transfer. Okay. Then another unit is refresh counter. This refresh counter is used for the purpose of refreshing. In the case of dynamic RAM, we have to dynamically refresh each row of the cell array. So for that purpose, this refresh counter is used. This will generate row address for each row. Then that row will be refreshed. Okay. Then this memory chip can operate in different modes. That modes can be selected by programming or setting control information within the mode register. Okay, that's about the different components or units within the case of a synchronous DRAM chip. So data held in the latches that corresponds to the selected column are transferred to the data output register, thus becoming available on the data output pins. Different modes of operation we already discussed. The necessary control signals are provided internally using a column counter and a clock signal. New data can be placed on the data lines in each clock cycle in the case of a block transfer. Next, we can consider the burst read of length 4 in an SDRAM. Burst read means block data transfer, or we can say as a fast page mode operation. All actions are triggered by the rising edge of the clock. So we can consider the clock the different timing diagram corresponding to the burst read. So clock is there, then read-write signal, RAS, cache, address, data. Initially, the RAS, raw address stop, is activated. It is an active low signal, so it is activated like this. And the raw address is placed on the address bus. Then the RAS will be enabled and the raw address will be latched into the raw address latch. So the raw decoder will decode that address and the corresponding raw will be activated or selected from the cell array. Okay. So the memory typically takes 2 or 3 clock cycles to activate the selected raw. So after that, column address is latched under the control of cache signal. That is, the column address is placed on the address bus, multiplexed address bus. And CAS, column address stop, is now active. RAS is now disabled. Okay. Column address stop is now active. So the column address will be latched into this column address counter. This column decoder will select the corresponding byte or corresponding group of bits, and that will be available through the data output register, and that will reach us into the data bus. Okay. So after 1 or 2 clock cycles, data is available on the data bus. First group is available. Then the next groups will be available during the next clock cycles itself. So for that purpose, the column address counter will increment the value of the column address from here itself, and that address will be decoded by the column decoder, and the next group of bits will be selected from the same raw. Okay. Similarly, during the next clock cycle, next group of bits will be available. Next clock cycle, next group. So four such groups of bits are available because we have selected a burst read of length 4, that is set in the our mode and timing control block or unit. Okay. This is actually the fast page mode. Okay. Then we have to discuss the terms latency and bandwidth. Memory latency. The amount of time it takes to transfer a word of data to or from the memory. That is memory latency. Memory bandwidth. The number of bits or bytes that can be transferred in 1 second. That is known as the memory bandwidth. Then another special type of DRAM is double data rate SDRAM or DDR SDRAM. In the case of standard SDRAM, that performs all actions on the rising edge of the clock signal. A DDR SDRAM accesses the cell array in the same way as SDRAM, standard SDRAM, but transfers data on both edges of the clock. That is on rising edge and on the falling edge. The latency of these devices is the same as for standard SDRAMs, but since they transfer data on both